Now we're going to start looking at examples of working with simplifying using your properties. We're going to try to combine some of them together to hopefully help you go through it. You've seen examples of these before, so hopefully some of the basic ones come back to you a little bit. You will have some practice on your worksheet of some of the very basics, and then you'll also see some of the more advanced topics. So here's an example of a simplifying problem. I have division in here, I have exponents, I have the same bases in here, a whole bunch of different things to go along the way. So to begin with, think about when you're trying to simplify things. How do you work through it? First, start within your parentheses. Is there anything that simplifies in my parentheses? No. None of the bases are the same. I can't do anything with x to the 7th and y to the 4th. They don't have the same base. If they had the same base, then I could. So then I have to go out to exponents, and I have to work with the outer exponent. This 8 is outside of my parentheses, which means every single thing inside my parenthesis has to get it. So what I could do, you're not going to, but what I could do is I could write this out 8 times and do this 8 times so I can see what it actually looks like. That's very tedious. We don't need to do that because we know properties. We know that when we have an exponent outside of my parentheses, it distributes throughout that fraction bar, throughout the division. So this goes out here and it goes out here. Now what it means is it's x to the 7th to the 8th. And then over y to the 4th, and its exponent as well, is to the 8th. Now, not only did I have an exponent to a quotient, I now have a power to a power. Now, I'm going to write the other one as well. Same type of process. Y goes to the 10th, and then it goes to the 3rd. Over x goes to the 10th, and it goes to the 3rd. So now I have another power to a power property. So now I just have to go through and have to look at, okay, power to a power, what do? Multiply exponents. So my numerator is x to the 56th over y to the 32nd times y to the 30th, power to power, you multiply again, and that's x to the 30th as well. So now when I look at this, I have two fractions. Now if you remember multiplying fractions, for fractions, you multiply across the top, you multiply across the bottom. So I physically have to multiply across the top and the bottom, which means it just becomes one fraction. X to the 56th times y to the 30th over, order doesn't matter when I'm multiplying, so I'm going to rewrite this with my x first. I like to go alphabetically, but you don't have to. The reason I do it alphabetically, though, is now I'm looking at my x's and I'm looking at my y's. So now within this process, it's all multiplication and division, so I can cancel. I have 56 x's on the top, I have 30 x's on the bottom. Because my property says I subtract those exponents, so therefore 56 minus 30 is x to the 26th. Then I have my y's. I have y to the 30th over y to the 32nd. Now there's two ways you can do this. I like to just visualize it and see, well, there's 32 y's in the bottom, there's 30 y's on the top. So there's more y's left on the bottom, and specifically there's 2 of them. Okay. In my opinion, that's the easiest way to go about it, but it's not the only way to go about it. The other option that you could do is technically I'm subtracting exponents. So it's x to the 56 minus 30 and y to the 30 minus 32, which gives me x to the 26th, y to the negative 2nd. Then what I have to remember is no negative exponents. So since I have that negative exponent, I have to push that to the bottom. A negative exponent is not simplified. So elevator button takes the base and my exponent and pushes them down. So that gives me x to the 26th over y to the 2nd. Same answer. So whichever way you do it is fine. Just pick one way that works for you. Next example. So I have a fraction. I have to look at how do I cancel things out. It seems that a problem like this, where there's variables, it's a little bit easier to go through and do. In this problem, I have numbers. And by the way, if you try to punch this into your calculator, I believe your calculator will overflow. Because if you think about what 4 to the 2001 means, it's 4 times 4 times 4 times 4, 2001 times. Okay, really, really big number. Probably going to overflow your calculator. So because of that, I have to look at how else could I break this down. Well, if you notice, they both have the same bases. Okay, there's a base of 4 here and there's a base of 4 there. Since they both have the same bases, when bases are the same and I'm dividing, I subtract exponents. So I have this 7/2, that's just some number, times 4 to the 2001 minus 1997. And 2001 minus 1997 is just 4. So it's 7/2 times 4 to the 4th. I could put this back as a fraction, just over 1. Oops. So I have to figure out what 4 to the 4th is, multiply it by 7, and I'm dividing it. Oh, I miswrote that, I'm sorry. That should be a 2. So it's 7 times 4 to the 4th over 2. So calculate 4 to the 4th, multiply it by 7, divide it by 2, and you get 896. Again, you could have left them as 2 separate fractions. That's 7/2 times 4 to the 4th. 7/2 is 3.5. Multiplied by 4 to the 4th also gives you 896. Whichever way you feel comfortable with is fine. This is a fairly large number. You're definitely going to be using your calculator along the way for those. We are going to get to some, though, where you're not going to be using your calculator. So you will have to be comfortable working with fractions. I'll tell you this right now. Fractions are our friends. And it is important that you feel comfortable working with fractions. Not that you have to like fractions, but you have to be comfortable with fractions. Because now we start looking at fractional exponents. And we have to remember, well, what does a fractional exponent represent? If I ask you to simplify 32 to the 1/5, well, what does that mean? Now we have to think about what does fractional exponents work with. In fractional exponents, the denominator is always the root, square root, cube root, in this case, 5th root. It's the 5th root of 32. So what number times itself 5 times gives you 32? 2. Maybe a little guess and check to figure out what it is. Sometimes it might be a decimal. We'll leave these simplified, so we will leave them in radical form. But it's just 2. Next fractional exponent, 16 to the 3/4. As I said earlier, the denominator is always its root. So I'm going to rewrite this. This is the 4th root of 16 cubed. Now, I do not want you to cube 16 first and then take the 4th root of it. Mathematically, can you? Yes. Don't. Because first off, I don't know what 16 to the 3rd is, and I don't want to have to do that by hand. This is actually a really nice number. The answer to this is 8. But if you take 16 and multiply it by itself 3 times and then try to do the 4th root of that and know what that is, that's going to be tough. So instead, if you do your root first, you're going to break down your number easier. So ignore the 3 for just the time being. Ignore that 3. What's the 4th root of 16? What number times itself 4 times gives you 16? 2. And now, bring that exponent in there, and it's 2 to the 3rd. And there's your answer of 8. If you have your calculator, I mean, feel free. You can punch in 16 to the 3rd and then take the 4th root of it. However, in our next video, we'll talk about most of these exponent pieces we'll be doing without our calculator, so that you understand the properties of what exponentials do. Okay, so here's one throwing a bunch of pieces together for you. So see if you can do this one on your own. I will just give you the quick heads up that that exponent of 4 goes to every single base, goes to all 3 of those bases. The 3 goes to all 3 of the bases. So make sure you take it to each of the bases individually. So I want you to start it, see where you can get. I'll bring you back through and I'll go through it, but try it first on your own. So one of the things I do is I just take each individual piece and I start taking them to their exponents. That way I can figure out what every single element is. Now keep in mind it's all multiplication. Yes, I put a big multiply sign in the middle, but there's one in between every single term. It's all multiplication. Multiplication does not matter the order. So now I start going through and I start simplifying this. So I see 3 to the 4th. Well, I know 3 to the 4th, so 3 times 3 is 9, and then I have another 3 times 3, which is 9, and 9 times 9 is 81. Just some properties of going through math numbers in your head. The more math literate you are, the quicker some of this will go. And then my next one, I have x squared to the 4th. Well, power to power, I know I multiply, so that's x to the 8th. Y to the negative 3rd to the 4th. I'm going to do the power to a power first, which gives me y to the negative 12th. Some of you may wish to push that y to the negative 3rd to the denominator. Perfectly fine. I just would prefer to hold off on my fractions for the time being in this problem. Depends on the problem. Sometimes I'll do the negative first. Sometimes I'll wait on it. So just be careful with which way you're doing it. and make sure you understand why you can do it or why you can't do it. Then I look at 2 to the third, and that gives me 8. X to the negative fourth to the third is x to the negative 12th. And then y to the fifth to the third is just y to the 15th. So now again, this is all multiplication. There's just multiplication signs between there. Don't let that throw you off. Okay, one set of multiplication is not any more important than another. What I might do at this time is I might combine my coefficients together, my x's together. Maybe I'll push my y's if I want. You don't have to. It is totally your option. So I'm going to bring my coefficients together. So I have an 81 and I have an 8. So that multiplies together and gives me, let's see, an 81 and an 8. So 648. And then I look at my x values, and I'm going to write them together first so you can see them. I have an x to the 8th, and I have an x to the negative 12. Then I'll write my y's out together. I'm showing a lot of steps. By no means do you have to go through this process. You can shortcut some of it along the way. So then I see, okay, these are the same bases, and I'm multiplying, so I add exponents. So this is 648, x to the negative 4th. Again, same thing, bases are the same, so I'm going to add exponents, so y goes to the third. And then lastly, I have this negative exponent. Cannot have negative exponents, so you have to push that to the bottom. So it's 648. Y to the third is positive exponent, so that stays on top. And the bottom pushes your x to the fourth. Now again, this is one option to go about it. Some of you may have wanted to push those negatives right away, and maybe you would have done that from this step. I'm just going to show you that option too as well if you prefer that. So multiplying my numbers together gives me 648. X to the 8th is on top. Y is the negative 12, so I push that to the bottom right away. I took care of the 8. X to the negative 12th, I push that to the bottom. And the y to the 15th is up top. And then when I take a look, when I look at my x's, I have more x's on the bottom than the top, which is why there's x's on the bottom. And I have more y's on the top and the bottom, which is my y's are on the top. So either way you go through it, you're going to get the exact same answer. Just keep in mind, make sure that you are not making up your own rules and that you are actually going through using properties of exponents. And that's one of the big mistakes I see often is trying to make up your own rules that truly don't work. Okay, 2 more problems for you. So simplify this one. Go through, deal with your negative exponents. If you wish to do that first, push them around if you'd like, especially because there's so many negatives. If you don't want to, that's fine as well. But tackle this problem. I personally am going to shift my negative exponents around. So all my negative exponents that were on the top push to the bottom. All my negative exponents that were on the bottom push up to the top. Now I just combine pieces along the way. When I look at my x values, I have x squared on the top, x to the first on the bottom. So I'm going to have an x squared left on the top. Then I'm going to look for my y's. All my y's are in the bottom. There's one y here. Remember, y to no power is y to the first. And then I have 4 there, which gives me y to the 5th in the bottom. And then I look at my z's. I have 3 z's on the top and 1 z on the top. That gives me z to the 4th on the top. And that's as simplified as it can get. I started the problem wrong. I had 2 x's on the top and 1 x on the bottom. Hopefully you caught that. That gives me just x on the top. So real quick to this one, x is on the top, x is on the bottom, which leaves me 1x on the top. All my y's are in the bottom, which gives me y to the 5th on the bottom. And then my z's are all on the top, which gives me z to the 4th in the top. Sorry about that. So this problem that started here simplifies over there. One last one. This one I have it in radical form. Remember, you have to be able to go both directions with your properties. Now I'm giving you something with the 4th root. I don't have any numbers, so this one sometimes might make it a little bit more difficult. This problem does simplify, though. Because it's the 4th root, that's taking it to a fractional exponent where the 4 is in the bottom. Again, you've got to be able to go both directions with these properties. Now I know the whole product is taken to the 1/4. So each of these bases with their exponents goes to the 1/4. The first one here simplifies down. Power to a power. You have to know how to work with fractions. So x is my base. I multiply exponents. Off to the side, I have to multiply 12 times 1/4. It's 12, which is the same thing as 12 over 1. So when I multiply straight across top and bottom, I get 12 over 4. The other thing you're going to want to do is start simplifying. 4 goes into 4 once, 4 goes into 12 3 times. So my exponent that's left is to the third. Try to simplify before you go through the whole multiplication piece. If you can, it'll just make your numbers a little smaller to work with. Now the other part, my base is y, so now I have 3 times 1/4. When I look at this, nothing simplifies. Again, it's 3 over 1. 3 and 3 divided by 1 are the same thing. Nothing simplifies in the top and bottom, so this result is 3/4, which means this will not simplify down at all. So realistically, my y has an exponent of 3/4. Because they gave me this problem in radical form, it is ideal to leave your answer back in radical form. So now I have to rewrite this back out in radical form. This has no radical. This is x to the third times. There is a root because the denominator has a number. It's the 4th root of y to the third. That is your final answer. Remember, the top of your fraction, the 3, is the exponent it's going to go to. The bottom of the fraction is your root. So based on these couple of examples, hopefully this helps you put a bunch of the different properties together to work through them. Your worksheet, it's going to be crucial that you go through all of the different problems I give you, because you will notice a bunch of different types of situations, a bunch of different problems based on how they're put together.